Hello. So it's getting a little dark in my room, and my computer's not able to see the board that well. Um, I got my light on, but now it's putting like a glare right there. Again, I apologize. Doing the best I can with what I have. Okay. So we're gonna go through problem 45. It's on page 250 as well. It says a plane flies horizontally at an altitude of 5 kilometers and passes over a tracking telescope on the ground. When the angle of elevation is pi over 3, this angle is decreasing at a rate of pi over 6 radians per minute. How fast is the plane traveling at this time? Okay? So again, let's go ahead and draw a picture of what we're doing here, okay? So, right here's the ground, and somewhere on the ground, I've got a little tracking telescope. Now, it says this plane flies horizontally, okay? Now, where is the plane on here? Now, it says the angle of elevation is pi over 3. So, if I'm looking, it means the angle of elevation is from the ground level looking up, means going this way, means the plane's somewhere right here, okay? Again, you could already see what kind of shape we're going to use here. So if I just extend this further and drop this down, we've got a right triangle. Now this problem's going to be a little bit different. We're not going to be using the Pythagorean theorem here. They tell us that this angle theta is pi over 3. They tell us how high the plane is, so if I label this y is equal to 5 kilometers. We don't know what this x distance right here is. And they're asking us, how fast is the plane flying? Okay, the plane's flying horizontally. So that's the same thing as asking us, what is dx dt? That's what we're trying to find, okay? Now they also say that as this plane gets further and further and further and further, this angle right here is going to change. It's going to get smaller. It says it's decreasing, so they tell us that d theta dt is equal to pi over 6 radians per minute. Not only that, it's decreasing, so it's going to be a negative. Now, we've got a d theta dt, dx dt, dy dt. Now we're flying horizontally. We're not flying up, we're not flying down. Just pure horizontal, so this y distance never changes. Therefore, dy dt is equal to 0. Okay, so now here's why we're not going to use the Pythagorean theorem. They don't tell us this distance right here, even though we probably could find it, like the previous problem. Actually, we couldn't find it. We don't know this, and we don't know that. That would give us two unknowns. Not only that, they don't tell us the rate that this is changing. They give us an angle. They give us two of the sides. Okay, that would be the hint that you need to use right triangle trigonometry. Now, if you think back to your right triangle trig, you got SOHCAHTOA. All right, let's write it up here. SOHCAHTOA. Sine is opposite over hypotenuse. Here's our reference angle. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. From this reference angle, we've got the opposite side, we've got the adjacent side. So we're going to want to use tangent here. Okay, so let's go ahead and write our givens over there in the corner, and then we're going to write our tangent equation of the opposite over the adjacent. Alright, so we've got y was equal to 5 kilometers, dy dt was 0. We don't know what x is. We don't, dx dt, that's what we're trying to find. I guess I won't put a question mark by x. We don't have it. We have theta is equal to pi over 3. And we've got d theta dt is pi over 6 radians per minute. So, tangent of theta is equal to y over x. If you go back to our triangle, this was the opposite side, this was the adjacent side. Now, we could implicit differentiate right here and right now. However, this is a quotient rule. I don't want to do the quotient rule. So I'm just going to rearrange this equation by multiplying both sides by x. Because then I have a product rule here. I much rather do a product rule. Although, if you were to do it using a quotient rule, you will get the same exact answer if you do all the steps correctly. So we got x tangent theta is equal to y because these two cancel right there. Now I'm going to go ahead and implicit differentiate. We've got a product here, so I got to use the product rule. The derivative of x is just 1, but then I got to remember my dx, times the second function, tangent of theta, plus the first function times the derivative of the second function. The derivative of tangent of theta is secant squared of theta, and don't forget your d theta, is equal to derivative of y is 1, but you got to remember your dy. Now, I'm going to divide by dt here. dt there, dt there, dt there. Now, over on this right side, we know dy dt is equal to 0. Okay, so that just goes away. So let me rewrite our resulting equation. We've got dx dt times tangent of theta plus x secant squared of theta d theta dt equals 0. Okay, so let me go ahead and move this equation. I'm running out of room. Let me move this equation up to here. Actually, I'll erase all of it and move this up to here. But remember this equation. Remember the starting equation that we had because we're going to need it. Here, I guess I'll leave it right here. Now, our ultimate goal is to solve for dx dt. So, the first thing to solve for dx dt is I have to go ahead and subtract that piece over. So I'll do that right here, and then I'll write the resulting one up there. So minus x secant squared of theta d theta dt. So minus x secant squared theta d theta dt. So now you have dx by dt times tangent of theta is equal to negative x secant squared of theta d theta dt. So now if we want dx dt, we've got one more thing to do, and that's just divide by tangent of theta. So we get a final result of dx by dt is equal to negative x secant squared of theta divided by tangent of theta times d theta dt. Okay, now we know what theta is. It's pi over 3. We could plug those in. We know what d theta dt is. It's, I forgot the negative right here. It's negative pi over 6 since it's decreasing. we don't have x. We have an x right there. Okay? Might be a problem. It actually isn't. Let's go back to the very beginning of the problem. The very beginning of the problem said tangent of theta is equal to y over x. We know what y is. We know what theta is. So we could solve this equation. I'm going to do it really quickly and give you the result. X is equal to y over tangent of theta. Okay, so since we know it's y over tangent of theta, we can insert that in to right there. And then finally be able to get our answer. So just remember, x is equal to y tangent of theta. Yeah, I guess I could put it right here. Y over tangent of theta. So the final expression becomes, this is a negative. X is y over tangent of theta times secant squared of theta divided by tangent of theta times d theta dt. Now, if you want to simplify it a little bit, it simplifies the negative y secant squared of theta divided by tangent squared of theta times d theta dt. So this right here, I guess I'll box it, is our final expression for dx dt right here. All right, so now let's plug in our values. I can erase everything here. Move that down there. So here's our dx dt. So dx by dt is equal to negative y. Well, y is 5. Secant squared of pi over 3 divided by tangent pi over 3, that's also squared, and then times by negative pi over 6. So let's see, we've got a negative 5. Secant squared of pi over 3. So if you recall, secant is 1 over cosine. Cosine of pi over 3, the x-coordinate of pi over 3 is 1/2. But we're doing secant, so it's the reciprocal of that. 1 divided by 1/2, which is 2. Then we're squaring it. So this is going to be 2 squared. Let's see, we've got a negative pi on top from right here. And then tangent squared of pi over 3. Again, tangent of pi over 3 is square root 3. And then we're going to square everything. And then we got to multiply it by 6 on bottom. So let's see what our final number is. We got negative times a negative, which is a positive. We've got 5 times 2 squared. 2 squared is 4. 4 times 5 is 20. Divided by square root 3 squared. The square root and the squared are going to cancel. You're going to get 3. 3 times 6 is 18, and we still have that pi symbol, which then 20 over 18 reduces to 10 over 9 pi, and we want a dx dt. This is going to be in kilometers per minute. The actual numerical value of that, I'm not sure. Let's see, this is 1.111. times by 3.14, I'm going to guess 3.45, 3.5, something like that. And it's going to remember kilometers per minute, 3.5 kilometers per minute.